Okay, this video will be talking about second and higher order derivatives. Okay, all right. So far, everything that we've done with derivatives has been with f prime of x, right? We've been given f of x, and we've been asked to find the derivative. Okay, we've always been going from the f of x to f prime of x, or y to y prime. Okay, so what is a second derivative? What is a higher order derivative? Okay, it's not as scary as it sounds. Okay, the second derivative is simply the derivative of the derivative. Okay, can we take the derivative of the derivative? And the answer to that is yes, we can. Okay, we can keep differentiating. We can keep doing this process of differentiating, and nothing changes as we differentiate. Okay, so if I have 3x, if I have f of x, I can derive it, get f prime of x, derive it, get f double prime of x, derive it again, and just keep doing that until I get to however many I've done that process however many times I want. Okay. By the way, we read this as f prime of x or f dash of x. Okay, just as a reminder. F double dash of x is another way to read this, depending on which country you are from. Okay. Y, if I take the derivative of this, will be y prime. Okay, same thing. It's just a different type of notation here. Okay, y prime, y double prime, y triple prime, or some people say y super n. Okay, y to the nth derivative, or y super n. So y super 4, y super 5. Okay, this method, if we go by this way, we read this dy dx. This would be d 2y over, or sorry, d2y dx squared, or some people say d to the 2y over dx squared, or d squared y over dx squared, d cubed y over dx cubed, d to the n y over dx to the n. All right, in any case, what is important is that you recognize how many times these have been derived. Okay, so this would be, if you're ever confused with how to read it, just say this is the first derivative, second derivative, third derivative, and the nth derivative. Nth derivative being where this number is n. Okay, that number and that number. So please keep that in mind as we do this. Okay, you can keep differentiating, and it's not as difficult as it seems. Okay, we're just taking the derivative of the derivative every time. Okay, and we actually have applications for this. When we come to curve sketching, or when we come to physics, you will see that there is a lot of applicability, at least up to the second derivative. Usually once we go past the second derivative, there's not a lot of real-world interpretation that can go on. I guess you go up to the third derivative when we talk about physics, but really anything past that is just theoretical. Okay, so let's think about the second derivative. Okay, the second derivative is how fast the first derivative is changing. Okay, so it's how fast this tells me how fast this is changing, right? It's the instantaneous rate of change of this function, and this tells me how fast this is changing. In other words, it's telling me how fast this is accelerating. Okay, and we'll get to that in the next chapter. But just this is a reminder that this is useful. Okay, second and higher order derivatives are useful. They do have a purpose. We're not just trying to make you feel bad by doing lots of irrelevant math. Okay. All right, let's do a couple example problems. Find f double prime of x, given that f of x is x cubed minus 3 over x. Okay, so saying find the second derivative. So that means do the differentiation process 2 times. Okay, So f of x is x cubed minus, I'm going to rewrite this so I can differentiate nicely. That's going to be 3x to the minus 1. All right, so what's f prime of x or f dash of x? That's just very easy. That's the power rule here, and then I subtract those. So that's 3x squared minus 3 times minus 1 becomes plus 3. X to the power rule, take that away, take 1 away, that's minus 2. Okay, that's fairly easy. Let's try the second derivative, okay? If I take the second derivative of this, what do I get? Well, since I have a plus and these are both single functions of x, I can derive them separately and add them. Again, so this becomes 6x minus, this time 3 times negative 2 is 6, x to the minus 3. Okay, so that's it. That's my second derivative. Not painful at all. Okay, so please be familiar with this process. If I see f double prime of x, that means find the second derivative. Okay. Given, let's try another example. Given f of x is the cosine of 2x, show that, so this is a command term, this has a specific meaning, show that f to triple prime of pi over 8 is 4 root 2. Okay, so this is saying what is this? This is the third derivative, okay? So find the third derivative, plug in x equals pi over 8 into that third derivative, and then show that I get 4 root 2. Okay, so that's what it means when you have these show that situations. Okay, show that means start with what's given to me, use a series of logical steps and the information given to get to the desired result, which is this part right here. Okay, so let's start with f of x. F of x is the cosine of 2x. So I need to do the differentiation process 3 times, and then I'm going to plug in x equals pi over 8 into the third derivative. Okay, so what's f prime of x? Well, what's the derivative of the cosine? That's negative sine of, and this is a mini function, so I'm going to leave 2x there, using my chain rule, times 2. Okay? Now, what is this then? This is really minus 2 sine of 2x, right? Okay, what's the second derivative of that? Okay, if I take the second derivative of this, that becomes minus 2 times the derivative of sine of 2x is cosine of 2x. And then again, I'm going to do this chain rule. So I'm going to multiply this by the derivative of the inside, which is times 2. That can come to the front. That becomes minus 4 cosine of 2x. Okay, almost done. Find the third derivative, or the triple prime. Okay, and I chose to use 3 dashes here. You can do that, or use this 3 symbol with parentheses around it. Okay, f triple prime of x is minus 4 times, again I'm going to do this so you can see this is repeating. This is going to be times minus sine of x, or sorry, sine of 2x times 2. Okay, that becomes positive, so I end up with 8 sine of 2x. Now I need to find what this will be when I plug in pi over 8. So I'm going to change my notation here. F, the third derivative of f when x is pi over 8 is 8 times the sine of 2 times pi over 8. Okay, and what is that? Well, this becomes 8. This is just 8. That becomes sine of pi over 4. What's the sine of pi over 4? Pi over 4 is over here. That looks like it's going to be 45 degrees. So, and it's positive. So we have root 2 over 2, root 2 over 2. And that's my sine value, sine of 45. Okay, so this becomes 8 times root 2 over 2. And I'm almost done. You remember we said we're proving, basically. This is the same as proving. So I'm going to show that I end up with 4 root 2. Okay, that cancels, and I end up with 4 root 2. So I've successfully shown, through a series of logical steps, starting from what's been given to me, that f triple prime of pi over 8 is 4 root 2. Okay, so that is second derivatives and higher order derivatives. Okay.